Steve, and Andy, and Steve, and Andy, and Steve.
Hey guys, pretty soon a really rare event is going to happen.
Oh, am I getting married?
What?
Oh gosh, I haven't even picked out a dress.
No, man, I'm talking about a total solar eclipse.
Oh yeah. I have no idea what that is.
You know I can hear you, right?
Oh yeah, of course I did.
I had no idea he could hear me.
Anyway, a total solar eclipse is a really big deal. It happens every couple of years in certain parts of the world, but this year, on August 21st, 2017, it's going to be the perfect conditions for certain people in the United States to see it. It's the first time happening here in 38 years. Here, look at this map. This map shows where the eclipse is going to be visible. As you can see, there's a dark line across the center of the United States. These are the places where the total solar eclipse is going to be perfectly visible.
But what does a total solar eclipse even look like?
Here, check out this. When this total solar eclipse happens, people who live underneath that line that I showed you in the United States are gonna see the world go from a normal sunny day to have it being pretty dark out.
Hey, what if you're totally afraid of the dark? I mean, I'm not, but I have a friend who is.
Don't worry. If you live in part of the United States where that line's going to be crossing, it's only going to be dark for a few minutes.
That must look crazy.
You want to see what one looks like?
Of course I do. Show me.
This is video footage taken during a total solar eclipse from a few years ago. It took place in Australia. I had to speed it up a little, but as you can see, it's a normal day when slowly the eclipse occurs and it gets dark out. Here, check it out.
Now the $1 million question. What's for dinner? Can we have pizza? Because I'm kind of craving it.
Is that really your question?
Maybe. But I guess the real question is, what causes a total solar eclipse?
Do you mind if I use these things to show you?
Sure.
This big orange guy is the sun, this little gray guy is the moon, and this blue one is the Earth. As you know, the moon is orbiting around the Earth. It goes through different phases as it goes around us. You can check out a video about that up above. But as the moon orbits around us, we orbit around the sun. Well, a total solar eclipse is when there is a full new moon and it passes between the sun and the Earth. So there you have it. That's a total solar eclipse.
Eclipse? I've been calling it egg lips.
What are egg lips?
They're people who have eggs for their lips.
On Monday, August 21st, 2017, the moon is going to destroy the sun. Briefly, but don't worry, sun will return. For the first time since 1991, the United States will experience a total solar eclipse. In fact, everyone in North America will get a chance to see some version of this epic event. 500 million people will see the sun dim to some extent. But for the fortunate people on an epic path from Lincoln City on the Oregon coast to Charleston, South Carolina, they'll see one of the most dramatic and awe-inspiring events of the sky. And if you're one of the people along that path and you've got the proper eye protection, make sure you're wearing proper eye protection, you'll see a bite appear on the side of the sun. Over the course of an hour, you'll see more and more of the sun disappear, blocked by the moon. At the halfway point, the last remnants of the sun will be completely covered, casting the area in darkness. The sun's mysterious corona will appear as a ghostly halo around the moon, and the stars will come out for a few brief moments. You'll experience totality. And that's when the elder Lovecraftian gods will come pouring forth from this eldritch rift in space-time to consume the planet in madness. Or, maybe not. The ancient scrolls are a little unclear on this. What is clear is that the sun will return, slowly but surely, and then there'll be traffic jams as a huge population returns home, spiritually awakened by this momentous event. Will you be there? I will. So what's going on? What are the underlying geometries that create such a spectacular moment for us to witness? Eclipses are caused because of the orbital alignments of the Earth, Sun, and Moon. The Earth travels around the Sun and the Moon travels around the Earth. And when the Moon is in the Earth's shadow, that's a lunar eclipse. And when the Moon's shadow falls on the Earth, that's a solar eclipse. The Earth orbits the Sun at an average distance of about 150 million kilometers, and the Moon orbits the Earth at a distance of about 385,000 kilometers. But in one of the craziest coincidences, the size of the Moon and the size of the Sun are almost exactly the same from our perspective. The Sun is 400 times bigger than the Moon, but it also happens to be 400 times further away. The Moon is slowly drifting away from the Earth, so in a few billion years, this will no longer be the case. The Moon will no longer be big enough in the sky to perfectly cover the Sun. We don't get eclipses every month because the orbits of the Earth and Moon are slightly inclined from each other. Sometimes the Moon passes above the Sun, other times it passes below. From the Earth's perspective, you'll see the Moon chomp away and block the Sun. But seen from space, you'll get a better idea of what's going on. The Moon casts a shadow down onto the surface of the Earth. For the 2017 eclipse, the shadow appears in the Pacific Ocean and then races across the surface of the planet. For anyone actually caught in the shadow, they're able to see the complete eclipse, where the Moon fully blocks the Sun. For everyone else on either side of the shadow, you see a partial eclipse, where only a chunk of the Sun is blocked by the Moon. Every year, there are usually a couple of total solar eclipses visible from somewhere on the planet, and there are larger chunks that can see a partial eclipse. The Earth follows an elliptical path around the Sun, and the Moon makes its own elliptical path around the Earth. So the size of both the Sun and the Moon can be slightly different sizes in the sky. When the Sun's at its largest and the Moon is at its smallest, that's an annular eclipse. The Moon doesn't completely cover the Sun and create a special event of a total eclipse. And in a moment, I'm going to give you some recommendations on how to best watch and photograph this and any solar eclipse. But first, I'd like to thank Gordon Grant, David Connor, Jen Scott, and the rest of our 759 patrons for their generous support. If you love what we're doing and you want to get in on the action, head over to patreon.com/universetoday. If you're planning to witness the great American eclipse with your own eyes, you're going to want to get the most out of the experience, but you also want to be safe. If you look at the Sun, even briefly, you can permanently damage your eyes. You're absolutely going to want some kind of protection. There are ways that you can observe the eclipse indirectly, like using a pinhole to project an image of the Sun onto a piece of paper, and that's okay, but you're really just going to want to be able to look at it. So right now, today, while there's still time, go online and order yourself a pair of proper eclipse glasses. Any listing should say that they are CE and ISO certified for safety. But even so, you shouldn't need to pay more than a few dollars for each pair. You can't use regular sunglasses, no matter how cool they make you look. Then you're safe to watch the Sun directly through the eclipse glasses. If you want to take things to the next level, you can project an image of the Sun onto the ground or a piece of paper with a sun funnel. I'll put links in the description for how you can build one. You can also project the light from the Sun through a pair of binoculars or a small spotting scope onto a piece of paper. It's a little dangerous, however. For starters, if you look through the unfiltered binoculars at the Sun, even for a second, you'll be getting a magnified light in your eyes and you'll be permanently blinded in moments. It's also hard on the optics of the binoculars or the telescope, and you can melt the glue and plastics inside and pretty much destroy it, so be careful. And I have learned this from personal experience. So it's best to get your hands on a solar filter. There's some good manufacturers that produce high quality solar filter material that you can put over the front of your telescope or binoculars to block most of the light and allow you to see what's going on. But really, I just recommend that you wear a set of eclipse glasses and call it a day. Next up, taking pictures. If you've got a good camera with a telephoto lens, you could take some cool photos of the eclipse. Once again, you'll want to be really careful because the light can damage the optics of your lens and camera. Use a long lens, like 300 millimeters or greater, and do a bunch of tests with the Moon before eclipse day. Especially figure out your focus point and put a piece of tape on your lens so you're not fumbling around when it's happening. But I've also talked to a bunch of people about what to do, and here's the advice I heard time and time again. If this is your first total solar eclipse, don't bother trying to take pictures of it at all. Just appreciate the experience without the stress of trying to capture it with a camera. Take pictures next time, once you're hooked. That's what I'm planning to do. As the partial eclipse begins, you're going to see the landscape darken around you so slightly. Less and less of the sun is providing illumination. As totality approaches, you might even be able to see the shadow of the moon racing across the landscape towards you. Moments before totality, there'll be tiny beads of sunlight at the edge of the moon as it blocks the sun. You're seeing sunlight slipping through tiny valleys in between the mountains on the moon. That totally blows my mind. Finally, we'll reach totality, and for a few brief moments, it is safe to look at the sun without any eye protection. But be careful, because after just 2 minutes of totality, the first spots of sunlight will appear on the opposite edge as the sun begins to return. The entire space community has been nagging you for the better part of a year to go and see this amazing eclipse, so I really hope you've got something fun organized, and you'll get a chance to see it with your own eyeballs. But even if you don't, you're in luck. There's going to be a second eclipse passing through the area in April 2024, giving most of North America a second chance to witness this amazing event. Are you planning to watch the August eclipse? Let me know your plans, and if you're watching this after the eclipse already happened, let me know what happened. How'd it go for you? Are you hooked? In our next episode, we'll consider all those asteroids hurtling around in space, who's keeping an eye out for them, and what strategies can we use to prevent an asteroid hitting Earth. Time again for a playlist. In this episode, we look at a recent episode of Astronomy Cast. You know, that other thing I do with Dr. Pamela Gay, where we can help you prep for the eclipse. Then, some new videos from NASA all about the eclipse. Finally, a video from PBS Spacetime. And that all starts right here. If you love what we're doing, and you want to get in the action, why am I having trouble with this?
This will be the first total solar eclipse in the continental U.S. in 38 years. The last one occurred February 26, 1979. Unfortunately, not many people saw it because it clipped just 5 states in the Northwest and the weather for the most part was bleak. Before that one, you have to go back to March 7, 1970. A solar eclipse is a lineup of the Sun, the Moon, and Earth. The Moon, directly between the Sun and Earth, casts a shadow on our planet. If you're in the dark part of that shadow, the umbra, you'll see a total eclipse. If you're in the light part, the penumbra, you'll see a partial eclipse. A solar eclipse happens at new moon. The moon has to be between the Sun and Earth for a solar eclipse to occur. The only lunar phase when that happens is new moon. Solar eclipses don't happen at every new moon. The reason is that the moon's orbit tilts 5 degrees to Earth's orbit around the sun. Astronomers call the two intersections of these paths nodes. Eclipses only occur when the sun lies at one node and the moon is at its new, for solar eclipses, or full, for lunar eclipses, phase. During most lunar months, the sun lies either above or below one of the nodes, and no eclipse happens. Eclipse totalities are different lengths. The reason the total phases of solar eclipses vary in time is because Earth is not always at the same distance from the Sun and the Moon is not always the same distance from Earth. The Earth-Sun distance varies by 3% and the Moon-Earth distance by 12%. The result is that the Moon's apparent diameter can range from 7% larger to 10% smaller than the Sun. It's all about magnitude and obscuration. Astronomers categorize each solar eclipse in terms of its magnitude and obscuration, and I don't want you to be confused when you encounter these terms. The magnitude of a solar eclipse is the percent of the Sun's diameter that the Moon covers during maximum eclipse. Solar eclipses occur between Saros cycles. Solar and lunar eclipses recur every 6,585.3 days, 18 years, 11 days, 8 hours. Scientists call this length of time a Saros cycle. Two eclipses separated by one Saros cycle are similar. They occur at the same node, the Moon's distance from Earth is nearly the same, and they happen at the same time of year.
On August 21st, 2017, the Earth will cross the shadow of the Moon, creating a total solar eclipse. Eclipses happen about every 6 months, but this one is special. For the first time in almost 40 years, the path of the Moon's shadow passes through the continental United States. Everyone there will see the Moon at least partially block the Sun. People within the path of totality, shown here in red, will witness a total solar eclipse. For them, the Moon will cover the Sun entirely. The sky will become twilight, the air will cool, the stars will appear, and the black disk of the Moon will be surrounded by the pale, streaming halo of the Sun's corona. Totality will last for 2 minutes or a little more, and it will be visible along a swath that crosses the continent, from Oregon to South Carolina. For some, it will be the spectacle of a lifetime.
On August 21st, more than 300 million people could potentially view the total solar eclipse. NASA wants everyone to watch the celestial phenomenon safely. A partial eclipse will be visible in every state, and the total solar eclipse will happen in 14 states. So how can you observe it without damaging your eyes? The only safe way is with special solar lenses, such as eclipse glasses. According to NASA, viewing glasses and solar viewers should have certification information on their packaging and be sure they're not more than 3 years old. More importantly, do not try to use regular sunglasses, even if they're dark ones.
Mama screamed, "It's really weird. The sun is gone. It's disappeared. It was here, but now it's done. I'm sure gonna miss that yellow sun." We all yelled, "Oh, Mom, gee whiz. The sun is where it always degrees is just tucked in behind the moon. The sun will be back very soon. So listen, Mom, just read our lips, just say it twice, solar eclipse. So listen, Mom, just read our lips, just say it twice, solar eclipse.
Solar eclipse. Solar eclipse. Solar eclipse. Solar eclipse.
The sun's sitting back behind the moon, but it's gonna be front and center really soon. I said the sun's sitting back behind the moon, but it's gonna be front and center really soon. Daddy screamed, the sun went dark. How will I take you to the park? I'll sure miss its rays so gold. Without the sun, it'll be so cold. Daddy, listen, don't get sad. The sun's still shining, you'll soon get glad. The moon's between the sun and us, blocks our view, don't make a fuss. So listen, Dad, just read our lips, just say it twice, solar eclipse. So listen, Dad, just read our lips, just say it twice, solar eclipse.
Solar eclipse. Solar eclipse. Solar eclipse.
The sun's sitting back behind the moon, but it's gonna be front and center really soon. I said the sun's sitting back behind the moon, but it's gonna be front and center really soon. And teacher said the sun blew out. We all began to yell and shout, "You're a really silly guy. A solar eclipse is in the sky. Blown out sun, you gone too far. Sun's still a big gas burning star. The sun's been blocked out by the moon. Sunshine will be back very soon. So listen, teach, just read our lips, just say it twice, solar eclipse. So listen, teach, just read our lips, just say it twice, solar eclipse.
Solar eclipse. Solar eclipse. Solar eclipse. Solar eclipse.
Welcome back. I'm astronomer and author Jeffrey Bennett, and this is the second video in the Eclipse set I've produced on behalf of Big Kid Science and Storytime from Space. The first video introduced the Great American Eclipse of August 21st, 2017. Here, I'll discuss more generally the questions of how and why eclipses occur. There are two basic types of eclipse. A solar eclipse, like the one of August 21st, 2017, occurs when the moon comes between Earth and the Sun, so that the moon's shadow falls on Earth. If you are lucky enough to witness a total solar eclipse, you'll see the moon gradually block more and more of the sun, and for up to a few minutes it will completely cover the sun's visible surface, allowing you to see the faint light of the sun's outer atmosphere, or corona. The second basic type of eclipse is a lunar eclipse, in which Earth comes between the moon and the sun, so that Earth's shadow falls on the moon. This series of photos shows Earth's shadow gradually covering more and more of the moon during a total lunar eclipse, with totality at the far right. Notice that Earth's shadow is clearly curved, a fact that enabled ancient scholars, including Aristotle, to recognize that our world is round nearly 2,000 years before Columbus ever set sail. Also notice that the moon takes on a red tinge during totality, created by the reflected glow of all the sunrises and sunsets that ring our planet at that time. These diagrams also show you why you are much more likely to see a lunar eclipse than a solar eclipse, even though both occur almost equally often. Because the moon is much smaller than Earth, the moon's full shadow, or umbra, traces only a narrow path of totality. As a result, very few people are in the right place to see any particular total solar eclipse. On average, a given location will have a total solar eclipse only about once every 375 years, though there is great variation from place to place. For example, a small region just south of St. Louis, Missouri, will have 2 total solar eclipses in just 7 years, the one of August 21st, 2017, and another on April 8th, 2024. Near the other extreme, Los Angeles last had a total eclipse in 1724, and will not have another until the year 3290. In contrast, the entire moon fits within Earth's full shadow, so a lunar eclipse can be observed by anyone who can see the moon in the sky when it occurs. As you can see here, that means anyone on Earth's night side. In other words, about half the planet can see any particular lunar eclipse, but only a small region can see a particular solar eclipse. Now that you know the 2 basic types of eclipse, our next step is to understand when eclipses occur. To do that, we must first review why we see phases of the moon. An easy way to understand moon phases is to take a ball outside on a sunny day, pretend the ball is the moon and your head is the Earth, and move your moon ball around you like the real moon orbits Earth. This painting shows the ball, or moon, as it would appear in 8 different positions as it moves around you. Notice that no matter where the moon is located, the half facing the sun is sunlit, while the other half is dark. However, from your viewpoint in the middle, you'll see different portions of the sunlit and dark halves at different positions. That is why we see phases of the moon. For example, when the moon is here, only the dark half faces toward us, and we cannot see it at all because it is located in the same general direction in the sky as the sun. We call this a new moon, a name that comes from ancient beliefs that the moon was being remade at this time. When the moon is here, the side that faces us is half sunlit and half dark. We therefore see what looks like a half moon, but this phase is officially called first quarter because we see it when the moon is 1/4 of the way around its orbit. You can understand all the phases the same way, but the other key phase for eclipses is full moon, which we see when the moon is on the side of Earth opposite the sun. It's also worth noting that the moon's full cycle of phases, from new to full and back again, takes about 29.5 days, which is the origin of the time period we call a month, which would be better called a month. We now switch to a view looking down on the moon's orbit around Earth, showing the full shadows that each world casts into space. Notice that the moon's shadow can touch Earth only when it is here, at the new moon position. In other words, a solar eclipse can occur only at new moon. Resuming the animation, we see that Earth's shadow can fall on the moon, creating a lunar eclipse, only here, when it is full moon. Let's now back away until we are looking down from high above our solar system, so that we can see the moon orbiting Earth while Earth orbits the sun. From this viewpoint, it might look as though we should have eclipses with every new and full moon, but we don't, and the reason is that the moon's orbit around Earth is slightly tilted to the Earth's orbit around the sun. To see the idea, let's focus on the moon's orbit in one place. This animation tilts our view so that we can see the tilt of the moon's orbit. The tilt is only about 5 degrees, but it means that the moon spends most of its orbit either slightly above or below Earth's orbital plane, crossing through this plane in 2 places that we call the nodes of the moon's orbit. Notice that this particular orientation cannot produce eclipses because the moon's shadow falls below Earth at new moon, and the moon is above Earth's shadow at full moon. A good way to visualize the three-dimensional nature of these orbits is to imagine Earth's orbit on the surface of a pond, so that the moon's orbit crosses through the surface. Here, we show the moon's orbit in 4 different positions over the course of a year. Now, the nodes are the points at which the moon splashes into or out of the water on each orbit. And if you connect them with a line, you'll see that this line keeps approximately the same orientation throughout the year. Notice that there are only 2 time periods each year during which the nodes line up close enough with Earth and the Sun to make eclipses possible. These periods, called eclipse seasons, each last a little less than 5 weeks, which is enough time for both a lunar eclipse at full moon and a solar eclipse at new moon. If this were the end of the story, eclipse prediction would be easy. We'd have eclipse seasons exactly twice a year, each with a solar eclipse at new moon and lunar eclipse at full moon. Eclipse prediction is more difficult because of several complexities. First, while the diagram may make it look like eclipse seasons should come exactly 6 months apart, they actually come slightly more often, about 173 days apart. This is because the nodes don't stay perfectly fixed in the moon's orbit. Instead, they move around much as shown here, but far more slowly. The combination of the 173-day period between eclipse seasons and the moon's 29.5-day cycle of phases makes eclipses recur in a pattern that repeats about every 18 years, 11 1/3 days, a time period called the Saros cycle. Many ancient cultures kept records of eclipses that enabled them to discover the Saros cycle and thereby to predict when eclipses would occur. You can see the idea on this map, which shows the paths of totality for total solar eclipses from 2017 to 2040, with paths of the same color representing eclipses separated by the Saros period. Notice that these paths, such as the ones for 2017 and 2035, also move about 1/3 of the way around the world, a direct result of the 1/3 day in the Saros cycle. This fact helps explain why ancient cultures had difficulty predicting the precise locations of eclipses, even when they could predict the timing. Precise eclipse prediction is further complicated by orbital details, such as the fact that the moon's orbital distance varies over its orbit, as shown here, and the fact that eclipses don't always come right in the middle of an eclipse season. As a result, most eclipses are not total. Instead, solar and lunar eclipses can each take 3 general forms. You already know that a total solar eclipse occurs when the moon's full shadow touches Earth's surface. Sometimes, however, a solar eclipse occurs at a time when the moon is relatively far from Earth in its orbit. In that case, we get what is called an annular eclipse, in which the full shadow does not quite reach Earth. The moon therefore cannot fully block the sun, even at mid-eclipse, which leaves a ring of sunlight, sometimes called a ring of fire, visible around the moon. In other cases, the full shadow may pass above or below the Earth, in which case we have only a partial solar eclipse, with no totality or annularity. Similarly, you already know that a total lunar eclipse occurs when the moon passes through Earth's full shadow. Sometimes, however, the moon may pass partly through Earth's full shadow so that we see only a partial lunar eclipse. Other times, the moon may pass only through Earth's partial shadow, or penumbra, creating what we call a penumbral lunar eclipse. A penumbral eclipse is barely noticeable to the eye. Finally, it's worth remembering that we see spectacular total solar eclipses only because the moon is just the right size and distance from Earth. If the moon were farther away, it would never be able to cover the sun completely. If it were closer, it would block the sun's atmosphere as well as its surface, so we'd never see the beautiful corona. Astronomically speaking, the moon's just right size and distance is an amazing coincidence because the moon has been gradually moving farther from Earth since the time it first formed. Many millions of years ago, when the moon was closer, it did cover the sun's atmosphere during eclipses. And about 1 billion years from now, the moon will have moved far enough away that total solar eclipses will no longer occur. That completes our introduction to eclipses. If you'd like to learn more about eclipses or astronomy in general, you can consult my textbook series, which is the source of the animations and much of the artwork in this video. I hope you have found this video useful and welcome your comments. If you'd like to support the creation of these free videos, please look for my books from Big Kids Science and consider making a tax-deductible donation to the nonprofit Storytime from Space program, which sends books and science demonstrations to the International Space Station, where astronauts video themselves reading and demoing, with the videos posted freely for anyone to use.
It rises in the morning, giving light to the land below it. It sets in the evening, leaving the world in darkness. It even provides the heat and energy necessary for life to survive on Earth. You know what I'm talking about, the sun. Because it is so important to us, the sun has been studied and observed since ancient times. Astronomers today still study it and are constantly learning new things about the sun, the center of the solar system. The sun is a star, not so different from the stars that can be seen in the night sky. It may look different, but that is because the sun is many times closer to us than any other star, which allows us to see how hot and bright it is. The sun may be close to us compared to other stars, but it is still very far from the Earth, about 93 million miles or 150 million kilometers away. Although the sun is so far away, it only takes sunlight about 8 minutes to reach the Earth because light travels so fast. Because the sun is so far away, however, it seems much smaller than it really is, more than 100 times the width of the Earth. The sun is so large that if it were empty, more than 1 million Earths could fit inside. The sun is the largest object in the solar system. In fact, if you collected everything in the solar system, including the sun, the planets and dwarf planets, comets, asteroids, and moons, the sun would account for more than 99% of it, with everything else adding up to less than 1% of the solar system. As far as stars go, however, the sun is average or even small in size. It is called a yellow dwarf, and there are billions of stars like it in the Milky Way. Like other stars, the sun is made of gases, mostly hydrogen, with a little helium, and only traces of other elements. These gases are held together by the sun's gravity, which creates such intense heat and pressure that it causes nuclear fusion, a process in which hydrogen atoms fuse to create helium at its core. The sun's core is about 27 million degrees Fahrenheit or 15 million degrees Celsius. By the time heat from the sun's core reaches its surface, temperatures have dropped considerably. The surface of the sun is only about 10,000 degrees Fahrenheit or 5,500 degrees Celsius. Unlike the Earth, the sun does not have a solid surface. You may be surprised to learn that the sun's gassy surface is not calm and quiet. Instead, the sun is constantly moving and changing, with sunspots, or dark patches of cooler temperatures, and solar flares, or eruptions of high-energy radiation, frequently marking its surface. All of the planets in the solar system, including the Earth, orbit around the sun. In turn, the solar system orbits around the center of the galaxy in which we live, the Milky Way. It only takes the Earth 1 year to complete an orbit around the sun, but scientists estimate that it will take the sun about 230 million years to complete an orbit of the galaxy. Since ancient times, humans have understood how important the sun is for life on Earth. Without the energy provided by the sun's radiation, the Earth would be dark, cold, and uninhabitable. Although it has been studied for thousands of years, there is still much to learn about the Sun. I hope you enjoyed learning about the Sun, the center of our solar system. It's the brightest and most noticeable object in the night sky. But if you spend much time observing it, you will see that the moon is never quite the same from one night to the next. The moon has something we call phases, which means that it appears to change shape a little bit every night. To understand why this happens, we need to talk a little bit about the way the Earth and the moon move together in space. The moon orbits around the Earth, much like the Earth orbits around the Sun. However, while the Earth takes about 365 days to travel once around the Sun, 1 year, the moon completes its orbit around the Earth in only 29.5 days, or about 1 month. That's actually where the idea of months came from, the time it takes for the moon to complete one orbit around the Earth. And the words moon and month come from the same root. Despite how bright it looks in the sky, the moon does not have any light of its own. It only appears to shine brightly in the sky because light from the sun hits it and bounces off. Just like the Earth, the moon has a day side and a night side, with half of it in sunlight and half of it in darkness at any one time. As the moon travels through its orbit around the Earth, that dividing line between day and night, called the terminator, is visible from different angles, giving the impression that different amounts of the moon are lit up on different days. The cycle of lunar phases begins with the new moon. At new moon, the moon appears completely dark because the unlit side is facing the Earth. New moon is the only time in the lunar cycle when a solar eclipse could happen, because it is the only time that the moon is between the sun and the Earth. After a few days, once the moon has moved along a little in its orbit, we can begin to see some of the moon's day side from Earth. What we see is just a thin slice of light called a crescent. We call it a waxing crescent because waxing means growing. The crescent moon will grow a little bit thicker every night until it reaches the next phase, first quarter. The first quarter moon is sometimes called the half moon because it appears to us that half of the moon is illuminated, but it is called first quarter because the moon is 1/4 of the way through its cycle. As the days pass, the moon continues to grow, soon entering its next phase, the waxing gibbous. Gibbous means humped or swollen, and again, we call it waxing because it grows thicker every night until it reaches the next phase, the full moon. A full moon is the biggest, brightest, and easiest phase of the moon to see. The moon rises at sunset and is up all night, so if you are outside and the sky is clear, it's hard to miss. The moon is halfway through its orbit around the Earth and is now on the opposite side of the Earth from the sun. During a full moon is the only time that a lunar eclipse can happen, because that is the only time that the Earth's shadow could fall on the moon. As the moon continues in its path, it appears to shrink again as we begin to see more and more of its dark side. A few days after the full moon, the moon will be a gibbous again, but this time it's a waning gibbous. Waning means shrinking or getting smaller, and so the moon will be waning for the rest of its orbit. The next phase is another half moon, but this time it's called third quarter, or sometimes last or final quarter, because the moon is 3/4 of the way through its orbit. Soon, the half moon shrinks into a waning crescent, which will continue to shrink night after night until it vanishes completely into the next new moon. Big and bright and beautiful. Different every night, but repeating the same cycle over and over. The moon is one of the best objects in the sky to observe, especially for someone just getting started. The next time you look up and see the moon in the sky, take a moment and see if you can identify which phase of the moon you're seeing, and try to figure out which one will come next.
From all over the United States. It's an opportunity that everybody should really try to take because they're few and far between.
Apart from the spectacular visible picture, the blocked sun also gives viewers the chills, in a literal sense. During a total solar eclipse, the temperature can drop as much as 35 degrees. That, of course, is nothing compared to the temperatures in outer space, where all the action is taking place. How cold can the universe get? That's what Carlo of Boulder, Colorado wanted to ask the universe. So he emailed us. What is the current temperature of the universe? And why is it so cold?
Carlo, that's a really cool question, if you'll pardon my pun. Here near the sun, we feel warm. But in outer space, the temperature of the universe is only 3 degrees above absolute zero. It's really cold. It's that cold because the universe can be thought of as an expanding gas, and it's been expanding and cooling for 14 billion years.
Where all the action is taking place. How cold can the universe get? That's what Carlo of Boulder, Colorado wanted to ask the universe. So he emailed us. What is the current temperature of the universe? And why is it so cold?
Carlo, that's a really cool question, if you'll pardon my pun. Here near the sun,
People will have an opportunity to get to the path of totality from all over the United States. It's an opportunity that everybody should really try to take because they're few and far between.
Apart from the spectacular visible picture, the blocked sun also gives viewers the chills, in a literal sense. During a total solar eclipse,
Well, we are now 1 month out from the big show in the sky. The total solar eclipse will take place on August 21st, and we have one of the best seats on the planet right here in South Carolina. Joining us now is NASA scientist Dr. Ivana Setanich. Now, we have been talking about this for some time now. Walk us through exactly what we're going to be seeing, because we are in what NASA calls the path of totality.
Yes, you guys are going to be experiencing all the goodies. So as the moon is going to position itself between the sun and the earth, this deep shadow is going to start traveling across the United States, starting in Oregon and ending up in your backyard. So everybody in this path of totality, where you guys are going to be able to see the dark in the middle of the day, but also see portions of the sun's atmosphere that we usually don't get to see. Everybody else is going to have a little bit less spectacular side, but regardless, everybody in the US are going to be able to experience this magnificent event. Remember, you have to be safe while observing these goodies that nature has given to us. So get yourself a pair of these safe solar viewing glasses and just enjoy the event.
Now, a lot of people are talking about what we're going to see, but tell us what we're going to feel.
Ooh, good question. So think about it. Sunlight is going to disappear. Probably temperature is going to start dropping. Humidity might change. And this kind of rolls back to this interaction between the sun and the earth. Moon will act as a shadow, as a cloud is going to cast a shadow. We at NASA know what's going to happen, where it's going to happen. So we can position our measurements on the ground, in the sky, and also from the satellites to actually getting better knowledge about this interaction of sun and the earth and the things that impact us. So there's like temperature, humidity, clouds, and so on.
So how is NASA using the eclipse to help people learn more about space itself?
Well, there's two ways, but I think the coolest way is by engaging people. So we have a citizen science app that can make you report all these things that you're going to experience back to us. So as I said, things are going to start changing, the sunlight's going to disappear, the clouds are going to start changing. So you can report all these things that you're observing using our Globe Observer app that you can download on any app store. You can also get yourself a simple thermometer such as this one and measure this temperature change that I just mentioned and report it back to us. By engaging you in a scientific process, that we make you learn a lot, but you also help us learn a lot about this important relationship between the sun and the earth.
So there you go. It is a team effort. Again, Dr. Ivana Sentinich with NASA, thank you very much for joining us. And don't forget, the total solar eclipse will happen on August 21st, and we will have total coverage before, during, and after right here on WYFF News 4 and on all our digital platforms.
This episode is brought to you by CuriosityStream. Hi everyone, I'm Diana, you're watching Physics Girl, and there's an imminent total solar eclipse. I know we all know about it already. We also know that I'm gonna be the one that doesn't get to see it because it's my fault. I agreed to go to Charleston. I'll be looking to start a post-cloud cover support group for any of you out there. Anyway, this got me wondering, do eclipses happen in other parts of the solar system? Like, does the Curiosity rover get to see a total solar eclipse on Mars? Short answer, no. Mars's moons, Phobos and Deimos, are too tiny to block out the sun completely. But you do get a funky partial solar eclipse, seen here, filmed by Curiosity itself. On Mars's surface, Phobos looks about 1/3 the size of the moon, and the sun looks about 2/3 as wide compared to how it looks on Earth. So you get that partial eclipse. Can we take a second to recognize how amazing it is that we have a video of what a solar eclipse looks like from the surface of another planet? Anywho, no Mars TSE, but Jupiter has 69 moons. Now we just need those moons to be big enough and close enough to Jupiter. It does help that Jupiter is way further away from the sun, so the sun looks a lot smaller in the sky. Which means Jupiter has multiple moons with the right conditions. In fact, Jupiter can have multiple eclipses happening at the same time. In 2004, the Hubble telescope took this photo. 3 of Jupiter's largest moons, Io, Callisto, and Ganymede, are simultaneously casting shadows on Jupiter, which means 3 total solar eclipses at 3 different locations on Jupiter. That's so many giant cover-ups. It's a conspiracy! Sorry. Saturn. Saturn gets some unique eclipses because of its rings. Technically, Saturn's rings aren't moons. They're belts of orbiting dust, ice, and rock, but they end up making these gorgeous shadows. Saturn sometimes casts a shadow on its rings, kind of like what happens with a lunar eclipse here on Earth. Here's some interesting stuff about Saturn. Saturn has seasons, cool, because its axis is tilted just like Earth's axis. But it takes 30 years for Saturn to go around the sun, so each season lasts over 7 years. And depending on the season, Saturn casts a different shadow on its rings, and its rings cast a different shadow on Saturn. Now, the object with the coolest eclipses, in my opinion, is Pluto. Yeah, Pluto is a dwarf planet and not a real planet, but whatever. Picture yourself on Pluto where the sky is also blue and the sun is a tiny pinprick in the sky. Because the sun appears about 40 times smaller in the sky on Pluto and 1,000 times dimmer than on Earth. Pluto's moon, Charon, looks super big because it's half the size of Pluto, and it's 20 times closer to Pluto than the moon is to Earth. So yeah, it blocks out the sun. As far as eclipses go, it's overkill. In fact, there was a period of time between 1985 and 1990 when Charon eclipsed the sun every day. Pluto eclipses. That being said, our eclipse here on Earth is pretty perfect. It's kind of an amazing coincidence that total eclipses happen here on Earth at all, because it's totally random that the moon would be exactly the right size and exactly the right distance from Earth. But it won't always be that way because the moon is moving away from Earth at 4 centimeters per year. So in 600 million years, we won't get total solar eclipses. Because this is how an eclipse happens on Earth. The moon orbits the Earth at a slight tilt of 5 degrees. Then every once in a new moon, that's when the moon is between the Earth and the sun, and the dark side is facing the Earth, the moon is just a line that it casts a shadow on Earth. If you were near the moon, it would look like this. This happens about 2 times every 3 years on a small sliver of Earth. This time around, the eclipse will be visible across a thin strip of the United States mainland. And basically every other part of the mainland, including where I live in San Diego, you'll be able to see a partial eclipse. So I'm super pumped for the 30% chance I have of no cloud cover and being able to see the total solar eclipse. It's been almost 40 years since the last TSE was visible in North America. So wish me luck. Thanks for watching and happy physicsing. This episode is brought to you by CuriosityStream, a subscription streaming service that offers documentaries and nonfiction titles from some of the world's best filmmakers, including exclusive originals. I recommend checking out Eclipse Across America. Get unlimited access today, and for our audience, the first 2 months are free when you sign up at curiositystream.com/physicsgirl and use promo code physicsgirl during the sign-up process.